Hello, Sauce here. This is a video lesson on investigating function of the form 1 divided by x plus h. I've written that in function notation. Take a look at this expression. It has two letters. X is a variable. H is not intended to be a variable in the traditional sense. When we choose a value for h, we create a distinct separate function of this form. For example, I could refer to the f function, but I'm going to write a 1 and read this as f sub 1, a version or a form of the general f function. And I'm going to create that by choosing a specific value for h. I'm going to choose 3. Again, I have the general function form, and when I choose a value for h, I create a specific function of that form. I'm going to investigate then this function 1 divided by x plus 3 and see what I can learn about the general form 1 divided by x plus any number h. Now in this case, I am going to use a t-table to organize points that I'll graph. I'm going to choose many values for x. I'm going to start at -4, and I'm going to increase by integer values to 4. When I do, in this column, I will put the values of this version of the function, f. The first value that I'm going to choose is 0. I often do because it's usually an easy number to work with. So if I put 0 in for x into this function, I get 1 over 0 plus 3, which is 1/3. I'm going to put 1 in. 1 over 1 plus 3 is 1/4. And I can see a pattern that the denominator is going to increase by 1 each time. Now let's go backwards. If I put -1 in, I get 1 divided by -1 plus 3 is 1/2. And I can go backwards and get 1 over 1. This could be simplified to 1, but I'm going to keep it as a fraction so it looks like the rest of them. Now there's an issue when I put in -3, because I get 1 over -3 plus 3, which is a 0 in the denominator. Can't divide by 0. It doesn't make conceptual sense to take something and divide it into no parts. When we put -3 in, we get the function, we say that it's undefined. UND is an abbreviation for undefined. The function is not defined when x is equal to -3. We could also say -3 is not in the domain of this function because it creates the division by 0 problem. I can put -4 in. When I do, I get 1 divided by -1. That's a -1 over 1. I have many points to plot. Remember, I'm in the habit of not drawing my axes until I have a good idea of what I'm going to plot with this information or on these axes. So that informs me how I'm going to label my tick marks. In this case, I can see that the output is going to be small numbers, fractions, and some negatives. So I'm going to choose 5 boxes to be the interval of 1. That way I can divide up that space very well. And I'm going to choose my horizontal axis to increase by 1 each time. I'm going to identify where 4 is and -4. Let's plot some points. At -4, I have a value -1. -4, -1 is down there. I'm going to plot 0 now. 0, I got a 1/3. 1/3 is approximately there. And at 1, I get a 1/4, then a 1/5, then a 1/6, and then a 1/7. Let's go backwards. At -1, there's a 1/2. At 0, at -2, it's 1. So here's -2, up 1. And at -3, I have this problematic piece, this undefined location. What I typically do when I find something, a place that's undefined, is I will draw a dotted line to represent that location that's undefined in the domain. How do I connect these points? I have several points plotted here, and that allows me, because I've got so many points and I know that they're going to be connected by a curve, I can draw a curve fairly accurately to connect those. It's going to look like this. Now I don't have so many points on the other side, but if I put more information in my t-table and got some more negatives, what I'd find is that it mirrors this kind of curve. I have a value at -1, and it's going to get closer and closer to the x-axis, making the same kind of symmetrical curve. Looks like this. Let's observe what kind of function we have here. We could list its attributes like we've done before. Attributes of a function are the simple facts that we can state about the function that we can observe in the equation or in the graph. We could say that this place here that the function gets closer and closer to in both directions, but it never reaches because we can't put -3 into the function, but we can put all of the values just above -3 and all the values just below, and they create points that get plotted that get closer and closer, but never touch that line. This dotted line represents that location, and the dotted line itself is called an asymptote. It's a place in the graph that is approached by the graph, but doesn't reach or touch or intersect. So that is an attribute of this function. It has an asymptote, but an asymptote of a specific kind. This dotted line is vertical, so we call this kind of asymptote, where the graph approaches but doesn't reach, call that a vertical asymptote. I'm writing down an attribute of this function. It has a vertical asymptote at x equals -3. That's where the asymptote is, and that happens to also be the equation of the asymptote. If the asymptote of this line was to have its own equation, that would be it. Other things to say about this is there is another asymptote. If I put my pencil on the horizontal axis, then the pencil represents a line that is also approached by the values of the graph of the function. It's this behavior here that we can see that's heading towards that line but not quite reaching it. I can be seen more clearly here. The values of the function get closer and closer and closer, but will not intersect the x-axis, because the x-axis is also an asymptote. But it's an asymptote that's not vertical, it's horizontal. We call this a horizontal asymptote. And the equation for this horizontal asymptote, its location, is y equals 0. These are two things that can be said about this function. And there are many more things that can be said, a few of which we're going to put here. Often we're interested in intercepts. Where does the graph cross the y and x-axis? We can see where it crosses y right here. When we have a x value of 0, the y-intercept is 1/3. We can make a note of that. Y-intercept is equal to the y value when x is 0, and that is 1/3. What about an x-intercept? Where does this cross the x-axis? It doesn't. The x-axis is an asymptote. It's a place in the graph that the graph is approaching but doesn't reach. So we could say that it has no x-intercept as an attribute of this function. Another thing we often say about functions is what family they belong to. The family of equations that this belongs to is the simplest form of the equation 1 divided by x plus h. And it will be in its simplest form if h is 0, because then the equation is simply 1 divided by x. That is a parent function. It's the simplest form of a family that we call hyperbolic functions. So this is a hyperbola. it belongs to the family of hyperbolic functions. We could also state the domain and range, something that is typical to do, and we will do that here. The domain of this function, f sub 1, are all of the values that are appropriate to put in for x. And the domain is not all real numbers because there is one value that causes the problem of dividing by 0. So we cannot put -3 in. -3 is not in the domain of this function. There's several ways to state domain and range. We're going to choose to say that the domain is all real, but not x is equal to -3. Everything but -3. Range, all the values that can come out of the function when you put all of the domain in. The possible output of the function is the range, and we can see from the graph, we could be convinced that every y value is possible except for that one place where we will not get 0 out of the function. There is no value that we can put into the function that will output 0. 0 is also an asymptote of the function. So we could say that the range is all real numbers, but not 0. I could state it just like I did for the domain, but I'm going to choose a different way to say the same thing. I'm going to use interval notation to say that the range is the interval, the numbers between -infinity and 0. And notice in this interval notation I use the rounded brackets because I can't ever get to -infinity. So I use a rounded bracket to say that it goes there but can't be exactly -infinity. It doesn't make sense. Infinity is not a value. And I have a rounded bracket at 0 to suggest that I get all the way up to 0, but I do not include 0 itself. So rounded bracket is the notation that means that up to but not including that number. And I have another set of numbers that start at 0 but do not include 0 and go all the way up to positive infinity, but can't include infinity because infinity is not a value. So here are 7 things that can be said about this function, 7 attributes to describe this function. What about the general function itself? 1 over x plus h. What is it about this general form that can be said? What kind of attributes does that general form have? It's going to have all of these attributes, but the location of the asymptote is going to be different for every different value of h. So if I choose a value other than 3, then it will have all of these same attributes, but the specific location of the vertical asymptote will change. It'll still be, any function of this form will be a hyperbola. It will have a vertical asymptote and a horizontal asymptote, but the locations of these things are going to be subtly different. How? A graphing tool would be very useful in graphing many versions of this function to see how the value of h affects the location of the vertical asymptote and the y-intercept and the domain.